Hi everyone, let's talk about some rare divisibility rules for division by 7. The reason I call them rare is that they're not very well known, but they can come in handy sometimes. So I want to show them to you just in case they come in handy. But in general, they're not as elegant as the rules for, let's say, 2, 5, 6, 3, 9, 11. These numbers have really nice rules, but the ones for 7 are a bit unusual. So let's get into it. The first one, it has to do with the fact that 10 to the power of 3 plus 1 is equal to 1001, and that is equal to 7 times 11 times 13. So what that allows us to do is say that 10 to the power of 3 is congruent to negative 1 mod 7. So let me give an example how this would apply. We have the number 8641969. So 8641969. And that is equal to, we're going to break it up into groups of 3. So we're going to have this group here, we're going to have this group here, we're going to have 8 alone by itself because we don't have the other 2 digits. So groups of 3 starting from the right end, and the leftmost end might not have all 3 digits. It might just have 1 or 2 digits. So we have 8 times 10 to the power of 6 plus 641 times 10 to the power of 3 plus 969. And if we take it mod 7, then we can reduce these powers of 1000 by we can reduce them to negative 1 to the power of whichever power it is. So we get that this is equivalent to 8 minus 641 plus 969 mod 7. And if you look at what that is, if you do the computation, that is equal to 336 mod 7. And at this point, it's not entirely unreasonable to just do long division. You can do long division and find that 336 is equal to 7 times 48. But you might be wondering, is there a way of even avoiding this long division? And the answer is yes, and that brings us to our second divisibility trick for division by 7. And that is the fact that 7 divides 10x plus y, which is whatever number it is, let's say 336, if and only if 7 divides x minus 2y. And I'm going to prove that now, and then I'll apply it to 336. So this is the proof of this. N is congruent to 0 mod 7 if and only if 10x plus y, that's the way we're writing it, y is the units digit and x is the rest of it, is equivalent to 0 mod 7. And mod 7, this is 3x plus y, which is congruent to 0 mod 7. Okay, so this is what we know so far. Let's do another column, which is what we want. I'm going to work backwards a bit. So what we want is x minus 2y is congruent to 0 mod 7. That's true if and only if x plus 5y is congruent to 0 mod 7. And something else that we know is that 3 to the power of 6 is congruent to 1 mod 7, and 3 to the power of 5 is congruent to 5 mod 7. And we're going to use this. This is a bit out of the blue, which makes this divisibility trick a bit special. We're essentially using order theory here because 6 is the order of 3 mod 7. And so what we're going to do is multiply both sides of this one here by 3 to the power of 5. So we get 3 to the power of 5 times 3x plus y is congruent to 0 mod 7. and that means 3 to the power of 6x plus 3 to the power of 5y is congruent to 0 mod 7. And now what we get is that 3 to the power of 6 is just 1x, and here we have 5y, which is congruent to 0 mod 7. And that's exactly what we wanted to prove. So let's use this. We have 336 up here. So if we were to apply 336 here, then 7 divides 336 if and only if 7 divides 33 minus 2 times 6, which is equal to 33 minus 12, and that's equal to 21. And that's just 3 times 7. You should have that memorized. So what I recommend is using the first divisibility trick to reduce it to a smaller integer, and then use the second divisibility trick if you need it. Thanks for watching, and I'll see you next time.